Figure 13.10. So this figure looks at how various metrics in a population of fish or crustacea change with the age of the fish or target species in question. So running along the x-axis we have age, from age 0 fish going up to some infinite age, potentially as old as 100 years or more for some very long-lived species. And the three parameters that we're looking at are the number of fish in each age class, the weight of those fish in each age class, and the biomass of the fish at that age class. Now what we see in the top panel is that for the youngest age classes, the number of fish is very high indeed. So for example, a fish like a cod will spawn many millions of eggs. So from those many millions of eggs, millions of larvae will hatch, but the mortality rate of those larvae is very high because there are lots of predators that want to eat them. Many of them starve to death. So we start out at the youngest age classes with lots and lots of fish, but very rapidly as the fish grow and become older, the number of fish in each age class declines very rapidly indeed until eventually it plateaus out. Now if we think about the weight of individual fish, so imagine a larva hatching out from a fish egg, the weight of that fish is going to be very low indeed. And so as the fish start to grow though, growth rate will pick up as the fish become more competent, and it will reach a period where growth rate, so the change in weight of the fish per unit of time, is very high indeed. And eventually though, as the fish become sexually mature, their growth rate will slow down again, so the slope sort of graduates towards again a more of a plateau. So there is a point in the fish's life history when growth is diverted from somatic tissues into the production of gonads as the fish reach sexual maturity. If we then look at the biomass of fish in each age group, so while we have large numbers of very young fish, if we actually added them all up, put them on a scale and weighed them, their actual biomass would be very low despite the very high numbers of those fish. Now gradually the number of fish declines, but they're getting bigger and bigger and bigger with age, until eventually we see that we reach a peak of biomass contribution of particular age groups at some intermediate age. So for a fish like a cod, this is probably somewhere between 3 to 5 or 6, 7 years old. Then gradually, as the fish become older and older, and although the individuals themselves are getting larger and larger, there are fewer and fewer of them, and so their contribution to biomass becomes less and less.